Okay, here we go. Graphing quadratic, standard, and vertex form. So we are looking at a quadratic in standard form, and on the test you're going to be given this over here. And the first thing they ask you to find is the axis of symmetry. And what we're going to use is we're going to use this quadratic formula that they gave you, and we're going to remember we need negative b over 2a. Okay, so x equals negative b over 2a is how we're going to find our axis of symmetry. Remember, a is the number right here, so a is 1, and b is the number here, so b is 2. So we're going to have negative 2 on the top, and then 2 times 1, which gives us negative 1. That's my axis of symmetry. X equals negative 1. And just as a reminder, the axis of symmetry means we're going to go to the x-axis, we'll go to negative 1, and we're going to put a dotted line all the way up and down. This axis of symmetry actually splits our graph, our quadratic, in half. Super important. Okay, well, the really cool thing is the vertex. Let's switch colors. The vertex is going to be located on this axis of symmetry. We know the vertex is going to have the x value of negative 1. Now, what's the y value, right? Two ways to do that. You could either plug in negative 1 every single time you see an x, or you can let your calculator do the work. So let's remind ourselves how you let the calculator do the work. So on the calculator, you're going to hit the table button, which is right here. And then when you put in your quadratic, let's see, the quadratic is, so when you hit the table button, you're going to see y equals. And then our quadratic is x squared. So to get the x to come up, you are going to hit this. Oops, that is not an x, that's pi. Okay, you're going to hit this button right here, that's the x. And then, of course, to get the square, you'll go ahead and hit that button. So you'll have x squared, et cetera, et cetera. You'll put the whole thing in, right? Plus 2, and then you'll hit the x button again, minus 8. Now, be really careful. When we are separating two terms, the 2x and the 8, that is a minus that we're going to use in our calculator. We're going to use this button right there. So be really careful. Sometimes people use this button, and we don't want to. We don't want to do that if it's separating two different terms. All right, then we hit enter, 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 and I think we even hit enter a fourth time. Then what we're going to do is we're going to scroll up and down to find our answers that we need. And so when we come back over here, we're going to scroll to see, hey, when x is equal to negative 1 in our table that we see on the calculator, what is y? And we see that y is negative 9. So we've got our vertex, and we didn't even have to do much. We just had to push some buttons, which is pretty cool. So we go over to our graph, and we plot negative 1, negative 9, and it's the point right here. Your vertex will always be on your axis of symmetry. So now it asks for our y-intercept. We can find that two different ways. We can either plug 0 in for x, or we can say the number that's by itself, the constant that's by itself, that's going to be our y-intercept. But you know what? You can also let your calculator do the work. Just go ahead and scroll, and let's talk about y-intercepts and x-intercepts for a second. Okay, with a y-intercept, that means that where the graph hits the y-axis, right? And so the graph is hitting the y-axis. In this case, we see right here at 1, right? This is 1. And it's interesting, all the points that are on the y-axis have something in common. X is always equal to 0. So let's say you wanted to find the y-intercept and you didn't want to plug 0 in. You didn't want to remember anything. You're just going to scroll until you see on your table, on your calculator, where x is equal to 0, and whatever y is equal to, that's your y-intercept. So we're going to go ahead and do that with this. Either way, what we already did, it's negative 8. Okay, solutions. So solutions, that's another way of saying x-intercepts. So let's talk about x-intercepts. Those are they're two words to express the same thing. So x-intercepts, or solutions, are where the graph intersects the x-axis, right? And if you look at these 2 points, right, negative 2, 0 and 2, 0, you'll see they have something in common. The y is 0, and that makes sense, right? all the points on the x-axis, none of them jumped off of it. You know, like think about if you graph like 2 comma 3. Well, that would be going over 2 and then up 3, right? Instead of 2, 0, that just means go over 2 and not doing up or down. You're just staying still. So every single point on the x-axis has the y value of 0. So to find our solutions or our x-intercepts, we're just going to look at the table that we made on our calculator and find the places where y equals 0. And those are our solutions. So this is not the exact quadratic we're looking at. So I'm just kind of telling you a shortcut to find the x-intercepts, to find the solutions. Once again, also a shortcut to find the y-intercepts. So it makes sense if you start thinking about the graph, but to find the y-intercept, you look at the table and find, hey, wherever x is equal to 0, whatever number y is, that's your y-intercept. Same thing with x-intercept. Wherever y is equal to 0 on your table, whatever x is, that's your x-intercept. So let's go back. Once again, that was not the graph for this. So we're going to go ahead and look at the table, and we're going to scroll up, we're going to scroll down, and we're going to find that negative 4, 0 is one of our zeros, and one of our solutions, rather, and 2, 0. So let's go ahead, why not? Let's go ahead and graph those. Let's see, I have negative 4, 0, and we have 2, 0. And we're almost done. Let's go ahead and look at the table. Since we have the table function pulled up on our calculator, let's go ahead and fill it in. And you're just going to scroll. You're going to see, hey, what's above negative 1? Well, we see negative 2, right? Negative 2, negative 8, negative 3, negative 5, 0, negative 8, and 1, negative 5. Now, on the test, you would go ahead and plot those points. Because I'm trying to make this video a little shorter. Let's see what we've got so far. A little shorter. I am not going to graph those. I'm just going to go ahead and connect. Let's see. My y-intercept is at negative 8. Once again, you could get a better looking graph if you went ahead and graphed all of the points that you see on the table. I am just taking a little shortcut here. Woo! Woo! Okay. Oops, it shouldn't be leaning back towards it, but okay. Not a bad looking graph. All right, the max or min. Well, when we see these arrows up here, this means that the graph is going up and up and up and up and up. There's no max because the max never stops, but there is a min. Now, for min and max, we're looking at the y-axis and the number. Now, the number's covered up, but that's really a negative 9 right there, right? So negative 9 is going to be our min. And now let's stop and talk about increasing and decreasing, because I think this is the hardest part. So I went ahead, now once again, we're going to come back to this, but I went ahead and did something different. Like, remember, this was me explaining x-intercepts and y-intercepts, but using something different to explain it. I'm going to do the same thing with increasing and decreasing. Let's see what this is doing. Okay. Increasing and decreasing. There we go. All right. So I want you to notice that we have two similar looking graphs. And what's similar about them is the axis of symmetry on both is x equals 2. Can you see that? This axis of symmetry is x equals 2. Now, once again, you don't have these on your paper for this video. This is just showing you a little shortcut to find increasing and decreasing. Okay, we're going to do the same thing no matter what graph we're looking at. See, our axis of symmetry is 2. We're going to put the 2 here, and we're going to put the 2 here. Okay, so same thing, obviously, 2 here and 2 here. Now, as we're reading the graph, and we're reading it like we read a book, we're reading from left to right. We notice that looking at the x-axis, what is to the left? A lot of negative numbers. We're always going to start with negative infinity. So as we're writing this down, we're going to write the same things over and over again. We're going to write parentheses, negative infinity, comma, whatever the axis of symmetry is. Okay. Then we're going to do the same thing, axis of symmetry, comma, positive infinity, because that makes sense as we're reading from the left to the right. If we're going to the right, there's just a bunch of big positive numbers. So every single graph you have, we're going to do this new thing. Okay. Now, once we're done with that, so we did the same thing over here. Once we're done with that, we have to say, okay, wait a minute. It's got a different color. It's got pink. Is this right here, is that increasing or decreasing? Well, let's look at the graph. This right here is describing what's happening to the left of the axis of symmetry. And so if you read it starting from way over here to the left and we're going to the right, look what's happening as we're reading it. It is heading down, down, down. It is decreasing. Okay. Now the right part, right, as we're heading up, up, up. This part is increasing. And so if we push this, we can see that we would write this for the decreasing, that for the increasing. Okay. The opposite's true for this, that when we're going left to right, this part is increasing and the second part is decreasing. All right, hopefully that helped. If it didn't, scooch back and listen to it again. That's about the easiest way I have to explain how to do this. Let's go back to our first problem, and we're going to do the exact same thing we just did. I'm going to try to make it as easy as I can. All right, we're going to write 2 parentheses, okay? We're going to always put negative infinity first, and we're going to put positive infinity last. Our axis of symmetry is -1, right? We're right here at -1. We're going to put the -1 here and the -1 here, right? So our axis of symmetry always goes here and here. Negative infinity always goes there. Positive infinity goes there. Now, this one describes what's going on the left side. And so what is happening on the left side? It's heading down. As we're going from left to right, it's heading down. So that is my decreasing. I'm going to write that one and the decreasing part. And then, of course, it makes sense to the right of the axis of symmetry. We are increasing. So this one to the right is what we write for the increasing. All right, we're going to go through the second one a little faster. But once again, please pause. If something doesn't make sense, all you need to do sometimes is just back it up and listen to it again, or slow me down. Like, slow down the whole thing. All right,